everyone. My name is Anne. This topic was presented in English. I'm a different developer in DataArt, as Paulina mentioned, and I have experience more than 6 years. My most experience was with the backend part. I'll try to present this topic from this side, but it can be also very interesting and maybe needed for everyone, because we have to know what happens in applications and why we can face with problems. So, it's not working.
No, so.
How to detect and troubleshoot performance issues. This topic is very large. I can't tell you about everything in this topic, so let's call like introduction to troubleshooting, because it's a very large topic. And
okay.
Can you please help me?
Yeah, it's working.
Yeah. Okay. I spent a lot of my time in projects to try and analyze what happens with performance, or why it happens in this case or in the other case. And I'll try to make my applications each time more faster, more sophisticated. But first of all, we should know how to diagnose these problems. And first of all, we should know how to gather this information about performance issues. In my experience and in my projects, gather information like first step from our QAs, our testers. They test our application, they give us some test plans, some test results, and we can predict what happens with this part of application. Can it be some problem with performance? Also, gather information about performance can be taken from users of your application, from customer. It's not a good idea, but it can be. Also, it can be used to login system to gather information, or maybe some errors in your application. The next step for diagnosis is verifying performance issue. This step is very important, because we have to know where this issue happens, at what part of your application, at what level in your application. It can happen in front-end part, in back-end part, and it can happen because of some network issues, etc. So you have to spend a lot of time for this step. After that, you have to classify performance issue and identify solution. And this is step for find out what can we do with this problem, what definitely happened, and how can be the solution on this issue. And after that, of course, the last step, solution implementation and verification. This step is end step, and as you know, it can be the result of the troubleshooting performance. Yeah. And I would like to split the third and maybe second step, it can be joined, for 4 levels. First level it is application. This level about your problems with the server response time, with maybe rendering front end. Also, it can be connected with some algorithm in your project. The next level is database. It is, MS SQL Server or Oracle or etc. And the problems can be happen there. For example, indexes, for example, not very optimized execution plan, or not very optimized store procedure. After that, it can be network issue, no internet connection, something happened with Wi-Fi in your server room, or it can happen. And the last one is hardware. It's not very common problems, because very common problems it's application and database, but it can happen. And I think you should know that this is also very important, because when we have a hardware environment with poor memory, with poor CPU quantity, it can involve some problems. Application issues. As I mentioned, server response time. What does it mean? This is an example of Chrome response for some requests, API requests. For example, this request is for authentication user. As you can see, it's very simple way to identify the problem. As you can see, you have this column time. In this column, you can see the time which is needed for this request. It's a good point, because we can know which exactly request can take a lot of time. So first step is to see network profiler in Chrome or in your own browser. And very common issue is also render response time. I'm not a front-end developer, but I can give you some points of this problem. For example, some developers at their first levels, first steps, they try to render everything in one time. It's not a good idea. First of all, you should render your layout. A user should see something in his monitor. After that, some main points, some main tables on your view. And after that, some pictures, some very heavy resources, etc. So it can be also an issue for the problem. And why can be the problem with server response time? It's a really large topic, and common issues, it's these golden rules, as I can tell you. First of all, never do anything more than once. It means that cache everything that you think you can code more than once. For example, you have some responses or some requests for users from New York, for example. You have to cache this. Or for example, you would like to request some books for this author. You have to cache this. Some cities, like a dictionary information, you have to cache this. It's very important, because it is cardinal error to retrieve the same date more than once. The next rule is don't do anything you don't need to. What does it mean? Don't try to reuse your code. Yes, it's a good idea to reuse your code. It's a really good idea, it's brilliant. But first of all, you have to know what do you need exactly. If you have a request for everything in your table or everything in your application, for example, exams with statistics for users, with some qualifications, with everything, you don't need to use this request for example, only information about how many exams was passed today. This is the main idea. And also, you don't need to use, for example, dependency injection with a lot of services or a lot of some resources in every controller, for example, because you don't need everything in this, but it can increase your performance. The next rule is get everything in one go. I mentioned it a little bit, but with details. For example, you need to know about exams for today. Also, you need to know about users who passed these exams. You don't need to make 2 requests. You have to only make a join, simple join, for joining this information. But sometimes developers try to make a lot of requests. Or, for example, you have a list of exams for today. After that, you have a loop for every exam. In this loop, you can request information about every user in this exam. After that, you, in loop, for example, you call information about every question at this exam. After that, you try to make a statistic for this exam. It's definitely better idea for use this approach. Try to make one request for everything, but without some additional information. It's a good idea to use lazy loading for these requests, because you make one request. After that, you decided that you need information about users. Lazy loading can help you not to make a new request. Of course, if you know how to make a good quality of code. I think we can make a little break for this quiz. Paulina told me that you have time. You have a time for passing this quiz, and after that we can continue maybe.
I mean, it's up to you really, because it's supposed to be at 20 minutes.
Okay.
So maybe 10 minutes more.
Okay. About locking and synchronization. Sometimes you need to access for one resource with many threads. For example, you have to read a file with some information, but you have a lot of threads for this file. It's a good idea to make a lock in your code for this part, because when every thread tries to change this file, it can be a mess. So try to lock necessary code, but sometimes a problem can be in this that some developer try to lock method, not only part of code, a whole method. It's also a bad idea, because it can increase your performance. First of all, you have to investigate what exactly part of code you need to lock, and after that try to lock something. Unnecessary logging. This is important also issue, because from today's experience of my project, I have a developer who decided that we need to have a logger for our emailing. That's a good idea, login is very time. It's very hard procedure for our performance because, for example, if you log in only exceptions, it's good. When you try to log everything, for example, you try to log starting, send an email, you try to log in email, exactly email. After this, you try to log information about user who received this email, etc. It's a bad idea because you have a very bad experience with the performance in this case because you have to send a big amount of data to your server. Another situation of bad performance also is unknown how to use some collections in your project. For example, sometimes users try to developers try to use list, but they definitely don't need this list. They have to use certain list for certain some things, but they try to use general list for everything. It's a really bad experience because first of all you should choose collection which is needed for your requirements, and after that try to use everything for your requirements, not for general requirements. For example, you have to have a list for only 3 items, but you try to use also list. It's not a good idea. First of all, you should allocate memory for list for 3 objects and use it. After, when you allocate memory for list, it can increase your performance. Another situation with bad performance is not typical variable and also not typical collection. It can also increase your performance because you have to box and iBox your objects. It can increase your performance. Example, really common example in applications, in projects that I faced with. First of all, you have to have list with users with this email. It's for example. After that, you cast it to list because first of all it was a variable. After that, it will be list. List, yeah. After that, someone in maybe other method decided that you have to have users only with activated status. And after that, he decided to cast it as a variable. And in other methods, someone decided that we have to have only domain users with the domain status. And after that, we also cast it to list. It's a very bad approach because in this case, not even in this case, but in general, you try to get users from database by one parameter. After that, you have also 2 parameters for with this verb. So you can create only one query to database, but in this situation you have one query, and after that you try to loop these users and increase your performance with this looping. It's not a good idea. Another example from .NET. You have string and string builder in .NET. Sometimes, not sometimes, even in each project I faced with this situation that developers use string instead of string builder. But you should know that string is immutable. So when you create string, you should recreate object when you try to concatenate this string. So you have, for example, your error log or message. You add first part of this error. After that, you add the second part of the error. Or you try to get some points from list to one big string. It's a really time-consuming operation, and of course it increases your performance. Okay, maybe I'll continue with the whole presentations. After that, we yeah, database issues. Of course, from application issues, from this part of application issues, we can speak a lot. But if you have any question at the presentation, you will ask them, and we discuss this because it's a really large topic. Database issues. I think that this is the main issue that you can face with in your projects. ORM systems. This is entity framework and Hibernate, some other systems. This is a very sophisticated issue because using ORM systems is a really good idea. But sometimes they can generate a lot of mess in your project. You have a really simple query for your database, but ORM system can make this query so large, so with a lot of additional parameters, with a lot of additional information that you don't need. So we should be very we should mention that in this level you can happen with a lot of projects. This is the main project that I think in performance optimization. And after generate requests, the same as an ORM system. I can even join them in one point because after generate requests from ORM system is really it's not very optimized. So you should first of all try to understand what happens in this request, why ORM system make even this request, not another request. After that, indexes. Indexes is very important. Indexes are very important because indexes can help us to get information faster for some parameters. But even indexes can increase your performance, because if you have your indexes for every column in your table, you will increase performance. It's the main idea. So you should be very careful with using indexes. And execution plan. It can happen. It can show what's wrong with your request. What you can optimize, in your request. So you should see this execution plan and try to understand what happens in this. This is the simple request from one of my projects. This request was generated by entity framework. Surprise! And this is really maybe one of 5 parts of this request. This request was from a union, and as you see in I don't know do you see or not, a lot of constants. So it's not a good idea to ask entity framework to auto generate every request, because I think for this request it will be better to create one stored procedure and that's all. But we're faced with this. What can we do when we see that something happened? We can use our MS SQL profiler for first step and try to investigate what exactly a request is so time consumption. You see this event class, it's a request, you can expand this, and duration, it's the general information. And sorting by duration, you can see what exactly a request is very time consumption. And after that, you can copy this request and try to create execution plan for this request. And in this, it's not the same request, not because this execution plan is so little. And in this execution request, you can see what indexes do you have, what happens in this request, and it can help you to understand how can you optimize this request. Indexes. For example, we have table exam in our database. It's very predictable that you have to have a request for exams by users, exams by types, or exams by status. You can create these indexes, and in execution plans you can see are these indexes used or not. If you don't know what exactly indexes do you need in your requests, you can use a comment for example, in MS SQL, but in Oracle it can be another comment, show plan. This comment can help you to identify by what column you need, or by what columns do you need to create index for increasing your performance. Network and hardware issues. As I mentioned, it's can be internet connection, firewall in your servers, in your network environment, some memory. For example, you can have 2 gigabytes memory in the server, and of course it is so small amount of memory, CPU, and a lot of other issues. As a profiling tools, main profiling tools, we have a lot of profiling tools for .NET, for example, for SQL Server, but main profiler tools that we used in our projects is .NET Trace from JetBrains, Microsoft SQL Server Profiler. It's main profiler for I think even every project with MS SQL Server. And Mini Profiler is really a mini application, not application, even DLL for your application that can help you to investigate your performance, to investigate your problems with project. It can measure time consuming for some requests. Not profiler tools, but the other way that can you how can you measure this performance is using, for example, debug classes from .NET. Stop watching, start watching, log this information somewhere. It's very cheap but really effective idea to use this approach. And I think you have a lot of questions, so I hope for this. So I'm ready for questions. Yeah? Okay, one more additional information that I think you have to check at first time when you have your performance issues, that check your Git or check your SVN for last commits. I think you can find really a lot in these commits and can investigate the problem. Really? Okay. Let's try to quiz.
Dziękujemy bardzo Ani.